In this video, I will walk through example 2.31, which is to show that for three sets A, B, and C, that A minus B intersect A minus C is the same set as A minus B union C. So before we run through the proof of this, why this is true, let's just take a look at an illustration to sort of get an idea of why it should be true. So on this side, I'll put A minus B intersect A minus C. So A minus B, so I'll take everything in A and not anything that's in B. So that's all of this stuff. I'll use that red for that. And then how about I use green for A minus C? So A minus C would be all of, I don't want to include anything in C, would be all of this stuff. Their intersection would just be the stuff that I colored both red and green. So that's all of this stuff. See, that's just green, that's just red, so that's not in the intersection. So that's all of this stuff. So that's A minus B intersect A minus C. Now A minus B union C. Now B union C, think of all the stuff that's in B or in C. So this thing. And then do A, but not include any of the stuff that's in either B or C. So what's that? Everything that's in A, but I can't keep anything that's in C, union B. So that's, again, just this stuff. And so notice that these are the same. These are the same set. So that should illustrate why, give you an idea, some intuition of why these are the same thing. Let's actually prove this using logic. So remember, to show that two sets are equal if and only if this set is a subset of this set and this set is a subset of this set. So we have two things to show. So I want to show two things. One, that A minus B intersect A minus C is a subset of A minus B union C. So that is, if X is in here, then X is in here. I also want to show that A minus B union C, everything that's in here, is also in A minus B intersect A minus C. So everything that's in this set is also in this set. So let's prove this. All right, I'll tackle one first. So I want to give myself an arbitrary element of this set and show that it's also in this set. So let X be in A minus B intersect A minus C. So let's write this out. What does this mean? Then X is in A minus B and, right, using definition of intersection, and X is in A minus C. Now I'll write out what each one of these are. So this is similar to that earlier example I did where we take the sets and we start writing them in terms of logic, and then we'll build our way back up once we've broken these down all the way. Then X is in A minus B and X is in A minus C. So X is in A minus B. So I'll say since X is in A minus B, we have that X is in A and X is not in B. That's what that means. And since X is in A minus C, we have that X is in A and X is not in C. All right, so I want to build my way back up and remember what I want to show. I want to show that X is in A and X is not in B union C. So since X is not in B and X is not in C, that means X isn't in either B or C. So I'll say since X is not in B and X is not in C, we have that X is not in B union C. It's not in either B or C. So that's one thing I can deduce. And then we have that x, either way, we have that x is in A. So we have x is in A, and we have x is not in B union C. So x is in A, and x is not in B union C. Hence, therefore, x is in A minus B union C. And that's what we wanted to show, right? We just showed that A minus B intersection with A minus C is a subset of A minus B union C. So that's what we've shown, is that we have a subset inclusion there. So now I want to turn around and show the other subset inclusion. So now my starting assumption, rather than x is in A minus B intersect A minus C, I'm going to start with an x in this set and show it must be in this set. So 2, let x be an element of A minus B union C. So what does this mean? This means that x is in A and x is not in B union C. So since x is not in B union C, then x is not in B, and x is not in C. That's what it means to not be in B union C. So I have x is in A, and I have x is not in B. So I'll say, so x is in A, and x is not in B. Hence, therefore, x is in A minus B. Also, we have that x is in A and x is not in C, right? We have x is not in C right there. Hence, x is in A minus C. So x is in A minus C, A minus B, and x is in A minus C. Let me write that. So x is in A minus B, and x is in A minus C. Hence, by definition of intersection, x is in A minus B intersection with A minus C. And so what did we just show? We just showed that A minus B union C is a subset of A minus B intersection with A minus C. So we just showed that 1 and 2, that this set is a subset of this set, and this set is a subset of that set. So we showed subset inclusion in both directions. And so we'll say by 1 and 2, A minus B union C is equal to A minus B intersection A minus C. And that's a proof. So this is our little introduction into proofs. We can finally start proving things now with sets. And you see it just comes down to logic in this case, just writing out the definitions and making deductions. And that's the idea with these proofs. Okay, that's it. See you next time.